Hi, welcome to this video where we're discussing a balanced three-phase delta load with a lagging power factor. Now I'm using a motor here because we know that's a balanced load, meaning each phase is going to have the same impedance and the same power factor. So in this case we're doing a 0.94 lag and our motor has a current rating of 20.8. Now the thing here you would want to know is that when a motor has a current rating on the nameplate, that current rating is the line current. So what we know about this motor is that IA equals 20.8 amps, my line current. Same with IB and same with IC, right? It's all a line current value. Now what we're going to do is we're actually going to solve this question without doing any HV charts. We're just going to use the information we're given here. And we're going to use our two rules for balanced delta loads for current. So those two rules are I line equals I phase times root 3, and I line lags I phase by 30 degrees. So those are our two rules that we want to apply. So couple things we're going to do here. First thing is we're told my power factor is 0.94, I is 20.8. Now power factor lines up with my phase angle, right? So that power factor is actually within the phase what's happening. So we'll talk about that a little bit more. But what I want to do, first step, I'm going to find my phase current. So I'm going to go I phase equals I line divided by root 3. So I'm literally just transposing this formula to find my phase current. So when I do that math, I go 20.8 amps divided by root 3. In each of my phases, I am going to see 12 amps. Okay, that's my phase current in each phase. So IA to B equals 12 amps, IA to C equals 12 amps, IA to B, IB to C, and IC to A all equal 12 amps. So those are my phase currents. Okay, so IA to B equals 12 amps, IB to C equals 12 amps, and IC to A equals 12 amps. Awesome. Now what I want to address is this power factor. If there's a 0.94 power factor, that's within the phase, okay? So what I want to do is I want to find my phase angle. So another thing that we know is that cos theta equals power factor, right? So theta being my phase angle, the angle in the phase between current and voltage. So I'm going to transpose that, and what I end up getting is that my phase angle, or my theta, equals a 20-degree lag. So what I can do with that information? Well, in phase A, IA to B, we calculated as 12 amps. That current is lagging the voltage by 20 degrees, which means that here's my voltage for phase A. My current is going to be lagging by 20 degrees. It's going to put my current down here. So that puts it at 340 degrees, right? 360 minus 20 degrees equals 340. We do the same thing for all of them. My volts B to C is here. My current would be lagging by 20. That would put us here. That would be I, B to C, and which would put it at 220 degrees. And we do the same thing for the voltage across C, lagging by 20, puts it here, which means that my current IC to A is at 100 degrees. Fantastic. So now what we want to do, right? We've established where all our phase currents are based on the power factor in the phase and based on the fact that our phase current is just line current divided by root 3, coming from these three rules down here, which we just need to know. Now what I want to do is I want to calculate my line currents. Well, we know my values, right? We know IA, I'm going to put them over here, equals 20.8 amps. We know IB equals 20.8 amps. And we know IC equals 20.8 amps, right? Now that's great. What I don't want to do is, if I don't have to, is I don't want to do a whole bunch of HV charts. So I know I could go IA equals IAB plus IA to C, which would be the inverse of that, right? But that's a lot of work. So instead I'm going to apply these rules, which tells me that my line current lags my phase current by 30 degrees. So that being said, line A is going to lag phase A by 30 degrees, which is going to put it down here. IA. Okay, which means it is going to be at 30 degrees, 310 degrees, right? A 30-degree lag from my 340. I can do the same thing with B and the same thing with C. Here's my B phase. So C phase is going to lag by 30, which puts it at 190. That's IB is at 190. Phase C as well. My phase C current is at 100. My line C current is going to lag by 30, which is going to put it back here at 80 degrees. 80 degrees. All right, so there we kind of see the relationships between phase currents and line currents. And I could go about this the opposite way. I could have given you, 40 ohms of impedance in the phase, 480 volts, 40 ohms gives me 12 amps, and calculated it out that way. But we just kind of worked backwards from the end. So both different directions work really well. The key here is I had to know that these delta current rules, right? And then I can plot those all onto that phasor diagram. So thanks a ton for watching. Keep in mind this was a balanced circuit. And these do not apply in unbalanced circuits, but check out the rest of the videos below in the description and have a great day.